You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello, everyone. Thanks for being here today. I am Kirk Mona, and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Well, hello, everybody. Welcome back.
Hey.
Good to be with you.
Absolutely.
Well, I think we've touched on the subject of plate tectonics from time to time on the show.
Plate
I
tectonics.
mean, you have touched on the topic.
Yes, I have.
Tectonic.
I know you're a big fan. And I think Rachel has sung that song
Yes.
every time.
Every time.
It's a great song.
I feel like I should do an actual episode about plate tectonics and how it was discovered sometime because it's a fascinating story, but that is not what I'm talking about today.
No.
I know.
Okay.
There are a lot of interesting characters in it, though.
Mm-hmm.
Today, though, I'm going to talk about an amazing discovery that was kind of a side effect of the discovery of plate tectonics in the early 60s.
Okay.
Yeah, so after the theory had been put out there, scientists were looking for confirmation of it, naturally.
Of course.
And the National Science Foundation and the Scripps Institute of Oceanography out in California got together to build a research ship that would be able to take deep water drill cores of the ocean floor. It was called the Glomar Challenger,
Okay.
and it launched in 1968, and it proceeded to go on a 15-year expedition. I mean, I assume they came into port
Well, yeah.
Right.
occasionally. I don't think.
I would
wow,
hope.
it's a
I would hope so.
long time to be out
Start
there.
your own little garden on the ship.
Yeah, it's not a.
It's been 15 years at sea. Martha, I'll return home someday. Sorry, that was. I'm thinking Civil War reenactment. Go ahead.
Okay. Well, mostly they spent this time crisscrossing the Atlantic to take drill core samples to gather information about the Mid-Atlantic Ridge.
Mm-hmm.
They did take some
Nice.
side trips, though, and one to the Mediterranean in 1970 led to a remarkable discovery that I'm going to talk about.
Ooh. Well, I mean,
You know they were like, hey, it'd be cool? Let's go to the Mediterranean. I'm sick of being out here
right?
in the
Yeah,
Atlantic.
well-
this water's a
It was
little
a vacation trip. It was a
cooler.
vacation trip. Come
let's-
on.
Let's go somewhere nice and sunny and warm, where we can
That sounds
see
crazy to
land.
me.
Absolutely what happened. Okay, what did they discover,
Yes.
Victoria?
Well, I will tell you, but first I'm going to jump us back more than 100 years
Oh,
Oh.
to 1849. And Italian chemist Giulio Usilio was doing some experiments
What
with
a
the
name.
evaporation of seawater.
Okay.
Yeah.
okay.
So along the Mediterranean, that's naturally where he was doing his experiments, being Italian. And
Yeah.
he discovered that as seawater evaporates, stuff precipitates out of the water in a certain order,
Oh,
starting with
okay.
clay and moving on through various what are called evaporite minerals, including sodium chloride, good old table salt, and gypsum.
Yep.
Uh-huh.
So this was particularly interesting because in many areas bordering the Mediterranean, especially in southern Italy, there were thick deposits of salt and gypsum in the rocks, which it now seemed must have been left there by the evaporation of a massive amount of seawater.
Yeah,
Okay.
yeah.
So, starting in the mid-19th century, there was a suspicion that something had happened in the Mediterranean several million years ago that caused a lot of it to dry up.
Okay.
Ooh.
Yeah.
Yeah.
And a Swiss geologist, Karl Meyer Eimar, which, side note, by the way, his birth name was Karl Meyer, and then he hyphenated it with an anagram of Meyer, Eimar, because he was weird like that.
Sure.
All right. We can dig that here on this show. Yeah.
He was able to, but he was able to date the layers using fossils to the Miocene epoch, which is about 5 to 7 million years ago.
Okay.
And he called it the Messenian period, which is after the city of Messina in Sicily. So,
Okay.
back to the Glomar Challenger.
Okay.
It took some drill cores of the floor of the Mediterranean, and guess what?
Found
It showed
gypsum.
thick deposits of salt, gypsum, and other evaporite
Okay.
minerals.
Right.
Yeah.
In addition, some of the cores showed patterns and types of sediments that showed that the floor of the Mediterranean had entirely dried out.
Whoa.
So like wind-blown dust patterns.
Okay.
This was pretty mind-blowing.
Yeah, that's
So,
crazy.
Yeah, most
And
or
was this once, or they showed it happen repeatedly?
it had happened repeatedly.
Interesting.
Yeah. So what happened?
Yeah.
If you recall your geography, you'll remember that the Mediterranean is actually mostly a closed basin. It is
Yeah.
connected to the Black Sea at its eastern end through the Strait of the Bosphorus, which is in Istanbul.
Mm-hmm.
But then the Black Sea, doesn't go anywhere really. And to the Atlantic Ocean at its western end through the Strait of Gibraltar between Spain and Morocco, which is a pretty narrow passage. And even today, the Mediterranean is noticeably saltier than other seawater. Something I
Yeah.
can confirm from personal experience because there's relatively little influx of fresh seawater from the Atlantic, and the rate of evaporation is pretty high.
Huh. Crazy.
You float more in the Mediterranean than the Atlantic.
Oh, that sounds fun. Just floating on the water.
So the timing of all this is a bit debated, but geologists believe that the connection between the Mediterranean and the Atlantic closed for the first time around 5.96 million years ago due to some tectonics. And
Interesting.
then basically the Mediterranean had no water coming in from the Atlantic and a very high evaporation rate, as I mentioned.
Right.
So there was a bit of back and forth for several 100,000 years. So there would, water would not come in, and then water would come in and it would evaporate again. But around 5.5 million years ago, the gap shut tight for several 100,000 years. And the sea evaporated, except maybe some very briny pools in deep areas. But the Mediterranean, the average depth of the Mediterranean is 1.5 kilometers, almost a mile. That's the average depth.
Oh man.
Okay.
So that is
Wow.
that's a lot of
A
seawater.
lot
Yeah.
of water. Yeah.
Just gone.
Yeah.
It's also really hot there, though, too. One of the hottest times of my life was when I toured Pompeii, and I thought you could actually feel the volcano until I realized it was just the sun beating down upon me. Oh,
Totally.
my gosh.
So other interesting evidence that this happened, in fact, this is kind of more of the clinching evidence, is that the Nile and other rivers that empty into the Mediterranean had to go much farther now to reach sea level. And so they cut deep gorges along their lengths.
Okay.
Oh, and
The
those
lower
gorges
reaches.
are now under
Yes.
the Mediterranean?
Under the Mediterranean.
Gotcha.
Huh.
Cool.
Yes. One of the curious effects of this great drying out was that at some point, hippopotamuses were able to cross and establish themselves on islands like Malta, Cyprus, and Sicily.
That's so fun.
Nice. Yeah.
Of course they did.
Yeah. And once the Mediterranean reflooded, they were then isolated and became dwarf hippo species. The one on
so good.
Cyprus, yeah, it survived as late as about 9,000 years ago before finally becoming extinct.
Oh,
It was probably too tasty, is what I'm guessing.
Yeah, probably.
odds are high.
So about that reflooding, again, there is some debate over this, but there is evidence that when the Atlantic Ocean finally broke through at the Strait of Gibraltar, forming the Strait of Gibraltar,
Oh,
Mhm.
man.
Oh God.
there's
Catastrophic.
pretty good evidence that it happened in a relatively short period of time, say between 2 months and 2 years.
Oh.
Oh,
Oh.
oh boy, it's not good. It's not
Nope.
good.
One day
Yeah.
there is no water, and the next day there's all the water.
All the water.
Goodness.
Yep.
So at the highest, the rate might have been about 100 million cubic meters per second, which
Per
is
second?
about,
Oh.
per second.
Meaningless to my brain, yeah.
Yeah, which is about 1,000 times the flow of the Amazon River currently. Leading Yeah, leading
Oh,
to
my.
rates of sea level rise in the Mediterranean of more than 10 meters per day.
That's-
not great if the animals are living there.
Yeah,
that's
this
so
is known
many
as the
Rachels.
Yeah, it's a lot of Rachels.
Oh, gosh.
This is known as the Zanclean flood. And by contrast, if you remember, I did an episode about the Missoula floods in the western United States.
Yeah.
I talked
Yeah,
about it way back
yeah.
in episode 21.
Mhm.
So that had, they believe, a maximum flow rate of just 2.7 million cubic meters per second, or 13 times the Amazon outflow. So
And
this
what-
was,
Okay, 1,000 times. Oh gosh.
yeah.
Okay.
So a couple orders of magnitude higher there.
Just one
So
or
a lot.
two.
I'm saying it's a lot. Now, is there evidence of a large gorge then cut from like the Strait of Gibraltar into the Mediterranean?
Mm.
So that kind of water movement has got to cut a big gorge
Yeah,
itself, I would
Great
think.
question. So I didn't look into this a ton, but I read something that in a paper that said that they thought it might have been more of a like a slope there.
Oh,
Okay.
So I don't know. Yeah,
interesting.
not as much of a gorge as you would expect, but some gorge. Yeah,
I suppose to some point, if there's that much water, almost like overtopping a dam, it could just be that it probably had to be wide. I
Yeah.
imagine.
yeah.
Wow.
Anyway,
Fascinating.
so that I just I found that really
That's
really
amazing.
interesting, and I wanted to share it with you. So
Absolutely. Thank you.
Thanks.
you're welcome. We are going to take a little break, and when we come back, Kirk will have something else interesting for us.
Yay.
Great. I mean, yes, I will. Welcome back. Last week I sort of hinted that I was working on something that had to do with complexity. I want you to consider mass transit systems for a moment.
Yeah.
Like
It's not going where I
think
thought it
of
would
a
be.
major metropolitan. I know, right? Left turn. Maybe think of like a major metropolitan area's subway system.
Uh-huh.
Okay.
You got that in your head?
Uh-huh.
Yes.
So they're often quite complex, and obviously there's an intelligence to the planning that goes into them. You can't just have trains running willy-nilly. The cost per mile to dig tunnels and put trains in them is extraordinary, and every train goes to a specific neighborhood for a reason. You would not expect to like hop off a subway train and come up in the middle of a farm field, for example, as it would cost millions and millions of dollars to build it to that location. And ridership would not support such a decision, that the cows aren't, jumping onto the train.
Yeah.
Correct.
So because of the complexity involved and all of the decisions that need to be made, you could rightly assume that the presence of such a complex system would be evidence of intelligence and design. These kind of assumptions, though, get tricky when it comes to the natural world because we are surrounded by highly complex systems. And people have been tempted to look at those systems as evidence of like an intelligent designer behind it all. But people having trouble seeing how people have trouble seeing how like a complex system can arise from simple choices. Like I mentioned last week with the shape of the bird nest just being a function of the size of the
Right.
bird, right?
Yeah.
So I didn't choose a subway system as a random choice here as an example of a complex human design system. I chose one specifically, because of a very cool research project I saw that I wanted to share with you.
Okay.
So a number of years back, a group of researchers in Japan wanted to see if they could reproduce something with the same spatial complexity as the Tokyo subway system using something with the intelligence of slime mold.
Okay.
In fact, exactly the intelligence of
They're-
slime mold. They use
they
slime
use
mold.
The slime mold,
Slime
in other
mold.
words.
Okay.
Yeah, slime mold. So we probably need a little primer here on what slime mold is.
Okay.
First off, slime mold is not a mold. It's once again an unfortunate name that is stuck because the first people to discover it really didn't know what it was.
It's an animal,
slime
isn't
molds
it?
they were originally considered a form of fungus,
Okay.
but now they're not even in the same kingdom of life. In general, they're considered to be protista or protists. And if you remember from school, protists are one of the kingdoms of life. So they're not plants, they're not animals, they're not fungus. They
Yeah.
are their own special form of life on Earth, which I
Although-
know is like we want things.
We love that.
Yeah, to be honest, protist is like the everything else category, which
Yeah.
It is, which is also amusing, and there's lots of debate over that. It's like, I think we want everything to be in these neat little boxes, like plant, animal, and it's like, okay, yeah, fine, we'll have another group called fungus, but then it's like, hey, there's a bunch of stuff on Earth that just doesn't fit any of these boxes. It's life, but not as we know it. So they are really wild. Like they can live as simple single cell organisms, but they can also group together into a single large sort of group. And when they form this group, they literally begin to function as one larger organism. And they can even work together to move around and detect food and transfer nutrients to the rest of the group.
So it really is like somewhere in between an amoeba and an animal.
Group. They have a hive mind kind of thing.
I'm actually, amoeba would be a very good way to think about it. I'm actually going to, as I was researching this, I was looking up amoebas. Amoebas are not what we think they are. They're not just one thing. So I think I'm actually probably I have on my list to do a topic just on amoebas. And I think that might blow a few people's minds.
Probably, yeah.
Because amoeba does not refer to one kind of life. Amoeba is actually a way of living more than anything.
Way of moving.
Is sort of mind-blowing.
Yeah.
Yeah. So slime molds are often found in leaf litter. The most common one that I run across, and maybe the two of you have run across, is called dog vomit slime mold.
Yeah,
I've seen this one?
that one.
They got a branding problem.
Yeah, well, maybe not. It really does look a bit like a foamy, messy dog barf pile on the ground. It's kind of
really
bright yellowish. It's really something.
I think that's an apt name.
But importantly, it's a mess of dog barf that can move. It's
terrifying.
It's really something.
I don't like that.
So back to our story. The researchers in question used a species of slime mold called Phasarum polycephalum, and they needed to give the mold some information to see if it could self-organize. Now, in a real subway system, the information is population density. You start with a central station, and then you build lines out to where other larger population centers are located. So to recreate this, the experimenters used little bits of oatmeal. The larger the piece, the bigger the city it represented. They laid food out in a pattern that represented the population centers that were served by the Tokyo subway system. And then they introduced the slime mold to this space. And the mold began to spread and send out tendrils looking for food. And these tendrils aren't sent out randomly. When slime molds form a group, they can actually detect chemicals in the air that the food is giving off. So they are literally going toward that food. When they find the food, they would then spread out and look for more. However, the slime mold did not just spread out in all directions, like a mat. Tendrils that found nothing would disappear, and tendrils that found small amounts of food stayed, thin, and those that found large amounts of deposits of food grew thicker to carry more nutrients back to the entire system as the food was, digested and broken apart. So after some time, the slime mold figured out exactly the most efficient pattern of tendrils to most efficiently transport nutrients around the network of tendrils. And the amazing thing is that when you compare the photo of this network of slime mold to a map of the Tokyo subway system,
I'm looking this up right now.
Identical.
That's crazy.
Yeah, they are virtually identical. The slime mold self-organized into the same complex system that humans had designed, which is super cool. This is a pretty basic study, and there's probably more factors to consider when setting up transportation networks. So civil engineers probably don't have to worry about losing their jobs to slime molding anytime soon. But I thought it was a really cool example of how very simple rules and information feedback can lead to incredibly complex systems in nature. And researchers are looking at how things like slime mold can actually help us better understand how nature self-organizes, and also how we can possibly use things like slime mold to help us figure out the most efficient solutions to complex problems.
That's really fascinating.
If you want to read...
Kirk,
that's amazing.
That's crazy.
Yeah. It's cool. If you want to learn more about it, The study was published in the January 22nd, 2018 issue of Science. So check that out if you want to hear more. There's lots of other articles about it online too, but very cool thing to check out. That who knew that slime mold could make something so complex?
I didn't.
Nope. That's
Well, we're
pretty
gonna take
incredible.
very quick
Yeah.
break, and when we come back, it'll be Rachel's turn to amaze us.
Welcome back, everyone. Now, where I live, currently, there is about 2 feet of snow on the ground.
Yeah.
Amazing.
And
What a difference 100 miles makes. Rachel.
yeah, truly, it's astounding. And when there's snow on the ground, it makes me think of, snow, and made me think about snow, and it's just like,
Profound.
thanks. I tend to have those really profound thoughts. And Kirk, you actually talked a little bit about this way back in episode 20 when you were telling us all about all kinds of extreme weather. But it was part
that was a fun one.
2 of your extreme weather. You touched base a little bit about some of the extreme weather that happens on Venus.
Right.
Yeah. Oh yes. Yeah, it was extreme weather. First, I did extreme weather on Earth, and I did extreme weather on other planets.
Yes. So to recap for all of our listeners, if you've been with us all the way since episode 1, episode 20, it was a while ago for us. So, Venus was on the extreme episode because of surface temperatures that bonkers, like 900 degrees Fahrenheit, absolutely crazy.
They're high.
They're really high. And because of the sulfuric acid rain that rains on the planet and actually like evaporates before it even hits the surface of the planet. But have y'all heard about the snow on Venus?
No.
Snow.
I have not.
Ooh.
I'm gonna guess this snow is not on the surface.
I'm guessing it's not water snow.
Oh, this is fascinating. Okay, do tell.
So even with the crazy hot temperatures, there is snow that has been found on the higher altitude points and mountains of Venus. Of course, it's not like what we consider snow, what's outside of my door. It is not little frozen water molecules. This snow is made from heavy metal.
Oh my gosh.
We're talking like there's a bunch of big pile of like Danzig and Megadeth albums and
So because of the extreme temperatures,
Nice flaky lead.
because of the extreme temperatures on Venus, the planet's surface, especially the lowlands, which is covered in minerals and volcanic rocks and such, those minerals actually evaporate and become gas, float up
okay.
into
So hot.
because it's
Okay.
so hot. They enter the atmosphere and condense on the mountains, and they fall like little flakes of snow.
Oh my gosh.
Which is really cool. The snow itself actually is galena and bismuth.
oh, okay, makes sense.
Nope,
Yeah.
bismuthnite. Yeah, which also known as
Yeah, those are pretty
bi-
easily melted metals. That makes
yes,
sense.
both of which are heavy metals technically, but they have that, like you said, they can evaporate. So this was actually discovered by Laura Schaefer and Dr. Bruce Fegley Jr. We'd known for a long time that there had been that there was snow. They had discovered it in, I think, the 80s. They noticed that it was snow, but no one could figure out what it was. So these two,
Sure.
they were able to look at the compositions of the metals in Venus's lower atmosphere, and then compare it to what was absent in the higher elevations and which ones could actually condense. So they were able to figure out
Okay.
what that snow is actually made out of.
Very cool.
Very cool.
I'm pretty happy we don't have metal snow landing on my house. That sounds heavy to shovel.
Yeah. I mean,
Very.
the snow we get is pretty heavy as it is. But it's crazy because this metal is just snowing and it lands. It's closer to frost than it is to actual snow, but
Oh, because it's like it's not actually falling out of the sky. It's sort of on the surfaces.
more or less because
Right.
it is gaseous and then it forms on a lower temperature of the mountain itself. But
It was like a hoarfrost made out of metal.
yes,
Amazing.
That's pretty metal right there.
yeah,
That's
it
very
is. As I was researching this too, it made me curious what else might be weird snow. The other weird snow is on Mars, or at least in our solar system. Mars snows dry ice.
Yeah,
That's right, it does.
Very cool.
So for everyone else who doesn't know, that means it snows carbon dioxide. So it doesn't get water snow, but it does have carbon dioxide snow. It's a pretty short and sweet topic for me today. But I just wanted to talk about snow on Venus.
You
kind
got
of-
me. I was not expecting that.
I'm very excited that Kirk didn't know about this, especially since you did your episode on
I
talked
talked
about Venus. I did
Venusian
listen
weather.
to your that episode back again just to double check and be like, did
To make
did
sure.
Kirk talk about this? I hope he didn't talk about this, and you didn't. I'm like, ha 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 ha.
No.
Perfect.
Nice.
Cool.
So my sources today were the Smithsonian Magazine, Wikipedia, Popular Mechanics, as well as a Huffington Post article, Metal Snow on Venus, which all were excellent. So that's what I have for you all this week. I believe that's the end of this week's episode. So,
It is indeed. You
Oh,
have all survived.
congrats. Well, thank you all for listening. We'll see you next week. All right.
See you next week.
Bye.
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 Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.